Okay, perfect. So, yes, I'm employed at the Arctic University of Tromsø at the Norwegian College of Fisheries Sciences, and my PhD is part of the DSolve project, which goal is the reduction of plastic litter and its effects on the marine environment by replacing the traditional plastics that are used in the fishery and aquaculture industry with new biodegradable alternatives. So this is the management pertaining to our project. We have 6 main research areas. The research area 1 is its goal is the development of biodegradable polymers. Research area 2 is into the assessment of the biodegradability of traditional and biodegradable fishing gear and aquaculture equipment. The research area 3 does tests at sea, and the differences between traditional and biodegradable alternatives. Then the research area 4 is into the development of governance incentives to increase the use of biodegradable alternatives. The research area 5 is the research area I'm into, and we are into the quantification of the environmental effects of the traditional and biodegradable fishing gear and aquaculture equipment, and also in the development of sustainable solutions using life cycle assessment modeling. And lastly, we have the research area 6, which is into the communication and dissemination of results. So the title of my PhD work is The Inclusion of Ghost Fishing and its Effects on Ecosystems and Biodiversity in Life Cycle Impact Assessment Modeling. I have 3 mentors. You will see one of them is Professor Roger Larsen, who works at the Arctic University in Tromsø at the research group Harvest. Then on the right, we have Francesca Veronese, and she works at NTNU. And in the bottom right, we have Cecilia Askham, who works at Norsus. So a few words about life cycle assessment modeling. It's quite a complicated framework, but I will just give a little introduction about it. So it's a comprehensive framework for evaluating the flows and environmental impacts of products, services, and systems throughout their entire life cycle. It has 4 main phases. We have the goal and scope and the interpretation, which are quite easy to understand. However, there are 2 more phases, which are the life cycle inventory and the life cycle impact assessment modeling, which are quite complex. So a few words about the life cycle inventory. It's a phase of life cycle modeling involving the compilation and the quantification of inputs and outputs for a given product system throughout its entire life cycle. Meanwhile, life cycle impact assessment modeling is a phase also life cycle assessment modeling aimed at understanding and evaluating the magnitude and the significance of potential environmental impacts of a product system. This is done by using the environmental flows from the life cycle inventory phase and classifying them into relevant impact categories. And then when we have those impact categories, we use characterization factors to convert them into impact scores. And usually the characterization factors are defined by a fate factor, by an exposure factor, and by an effect factor. And the main goal of my PhD thesis is to develop these kinds of characterization factors for ghost fishing. And being able at the end of my thesis to compare traditional fishing gear and aquaculture equipment with biodegradable alternatives. So the first project that I had going on throughout this summer was an abandoned lost discarded fishing gear retrieval operation, which was done in collaboration with the Norwegian Directorate of Fisheries. And what we did, and the main goal was the retrieval, characterization, and documentation of ghost fishing in the gear that are yearly retrieved. And the main goal while we did it was because we wanted to standardize the relationship between ghost fishing biomass caught and the mass of abundant loss discarded fishing gear retrieved. And also we use some indicators to describe the ghost fishing impacts on species interest richness, dominance, biodiversity, and evenness. So the retrieval locations are reported each year by fishermen to the Coastal Guard. And then the Norwegian Directorate of Fisheries researchers took those positions, and we took a route that was most logistically feasible to do it. And actually the details of those reports that are done yearly by fishermen, you can find them on Barents Watch. The retrieval was done on the vessel Viking Bank, which is a pelagic trawler and seiner, which is 65 meters long and 30 meters wide. And it's quite a new ship. It's from 2021. And you may see a picture of it. So the retrieval was done by dragging anchors at the reported location. So where the fishermen reported the gear, we dragged the anchors at a speed of approximately 1 to 2.5 knots, depending on the weather conditions. And the tow I used was between 1.3 and 2 times the depth. And per location, we used between 20 and 30 minutes. And if we had several unsuccessful retrieval attempts, then we just went for another location. So we took the spatio-temporal data, so the GPS coordinates, the time and the date, the depth, and also we took information from the fishermen at which time the loss occurrence occurred, because it's an extremely important information to know how long the fishing gear was in the marine environment, which highly affects the catch rates, the catch efficiency of the fishing gear. And also we did thorough visual documentation through photographs and videos. And in this picture, you can actually see newly caught cod and saithe in approximately 30-year-old gillnets. And we know that because of the buoys, the circular buoys that you may find in the gillnet, because now the buoyancy in gillnets is provided by polyurethane in the top ropes of the gillnets. So each time fishing gear would be retrieved, I would take the taxonomically sorted catch abundance, and then I used literature to convert the length of the fish that was taken and also the carapace width of the crabs that was taken to convert it into biomass. I also did the quantitative assessment of the fishing gear that was retrieved. So the number of individual gillnets and pots, so-called units per fleet or string, the mesh size and the twine diameter of gillnets, the top and bottom rope diameter for also gillnets, the line diameter for pots, and also the marker buoy to anchor rope diameter for both fishing gear. And also we took the quantities and mass of relevant items such as buoys, anchors, flagmans, and stuff. And so something interesting that we wanted to think about is how to establish the most suitable unit measure. So because our goal was to standardize per amount of fishing gear, how much biomass is caught. And so in the study, we decided that for gillnets, we are going to use the gillnet netting because it's the main entangling material. Meanwhile, for pots, we use the entire structure because without the entire structure, which also has some metal in it, the catch of crabs wouldn't be possible. And for long lines, we didn't see any catch. So indicators were used to define the ghost fishing impacts. So the species richness was looked at, the dominance, biodiversity, and evenness. And we use the common species richness index, the Margalef's index, the Menck's species richness index, and also the Simpson's dominance index, the Shannon diversity index, and the Pilot evenness index. So since right now the draft of the paper is about to be published, unfortunately the results I cannot share with you, but hopefully soon enough I'll be able to share with you the publication. And the future prospect pertaining to this project was the inclusion of ghost fishing and its effects on ecosystems and biodiversity in life cycle impact assessment modeling through the development of effect factors. And also it's a framework for future retrieval operations that we plan to do next summer, and that we want to expand and mainly focus on gillnets and pots, because throughout this retrieval operation, this is what I can tell you is that gillnets have a higher environmental impact than pots. Meanwhile, for long lines, once the bait is gone, the ghost fishing effects that we saw during the retrieval operation were not visible. Of course, the long lines may pose an entanglement issue, but during our retrieval operation, we didn't see it. The next project I have, and I'm currently leading in Croatia, that's the reason why I'm here in the first place, is that of a long-term in-situ assessment of ghost fishing and its impacts on benthic environment in the Northern Adriatic. And so it's a cooperation between the research area 5, so the area I'm into, and the research area 3, which we have a project partner, the University of Split. And the main goal is a long-term in-situ study in Croatia, simulating the ghost fishing effects that are caused by conventional gillnets and pots. We didn't use long lines because, as mentioned before, once the bait is gone, we don't think there is much of a ghost fishing effect by them, except possible entanglements, which will be quite hard to quantify. So again, we're interested in studying the relationship between predetermined amounts of abundant lost discarded fishing gear and the resulting ghost fishing catches in the benthic and benthic bottom layer marine environments, with again the goal of the standardization of the relationship between ghost fishing biomass caught per amount of abundant lost discarded fishing gear. And also something that we can do throughout this experiment and that we cannot do throughout the retrieval retrieval operations is the changes in catch efficiency over time, because the retrieval operations just give us a short snapshot of the entire catch that was caught throughout time. So the site selection is called Valun in Bagnole, Pula, Croatia, and we decided to take this location because in consultation with local fishermen, because it's quite relevant to the community. And actually, I took a short video of the location while I was diving last year. So it's a little ridgy area that starts at around 10 meters and goes towards 33. So this is some of the biodiversity in the area. So we have some dentex, we have some spiny lobster, we have some European lobster, we have some conger eels, we have some redfish. So quite an interesting area. So the characteristics of the gillnets. So we plan to use two different gillnets and two sets of three fish traps. And as mentioned before, we intend to deploy them from 15 meters towards 33. The distance between the gear set in parallel will be 15 meters. Meanwhile, the distance between gillnets and traps 4. So with one dive, we can pass the entire gear. The monitoring will be done 2 times per month. If weather allows us, we plan to do it more frequently, but we will see how it goes. We plan to do a 6 months monitoring. So we will have a briefing. The site will be approached at the starting depth and marked with a buoy. And the catches in both the gillnets and the pods will be filmed with a GoPro. And also the lengths of the catch will be taken. So again, using the length to weight relationships for different species, we can get the biomass. So again, the future prospects of the project is the inclusion of ghost fishing and its effects in life cycle impact assessment modeling through the development of effect factors. And I plan to use this project as a framework for future expanded field-based projects encompassing not only more locations, but also abundant loss discarded fishing gear, different as abundant loss discarded fishing gear specifications, and also aquacultural equipment. And also what we would be interested in doing is comparing the impacts, so the ghost fishing impacts between the traditional and biodegradable alternatives. And lastly, the last project I'm working on is the fate of abundant loss discarded fishing gear in the Norwegian marine environment, which has a scope that's quite simple. It's modeling the fate of the fishing gear in the marine environment. So we are now working on such a model to monitor the fate, and it's mostly done in Python, GIS, and RStudio. So the main assumption that we are currently taking is that the fishing intensity and the amount of abundant loss discarded fishing gear are linearly correlated. And for this presentation, I did a simplified version of what we do have now. So in the top right corner, you will see the fishing intensity for trawls and seines for the year 2022 in Norway. So it's for every fishing activity for trawls and seines, it is mapped on this map. So it's more than 1 million of polyline features that have been sampled through density weighted sampling to make the 500 most representative spots, so where so-called hotspots, okay? And these hotspots have been transformed into POID shapefile, and that's the second picture that you may see. And then using the sea surface data from global current and coupled with the Lagrangian particle tracking model from the ocean parcels package in Python, we used it to track the dispersion of the positively buoyant abundant loss discarded fishing gear stemming from the Norwegian fishery industry. And in the first part of the model, the fishing gear is mostly located and gets beached on the southwestern part of Norway. And after a year, we expect most of it to end up in the Barents Sea and on the coasts of Nova Zemlya. And actually, some of the cleanup operations that operate in Norway said that our model seems to be correct when comparing to their cleanup operations. So the future aspects pertaining to this model is a better understanding of the residence time of fishing gear in spatially defined environmental compartments, which are of course affected by beaching, clustering, changes in buoyancy, degradation, the 3D structure of the water column, the re-release, polymer type, and stochasticity. We are currently working in collaboration with NTNU to add all of those features in the model, and we plan, in the recent future to have a really good understanding when it comes to the fate of abandoned discarded fishing gear in the Norwegian marine environment, which will again improve the available fate factors when it comes to life cycle assessment modeling. So yeah, the main goal of this entire project and this thesis is the understanding and addressing of the environmental impacts of ghost fishing on the Norwegian ecosystems and biodiversity. So these are a few pictures of the Arctic University of Norway and a beautiful snapshot of the city during the winter northern lights. That's from a hill above the city. It's called Fjellheisen. So absolutely beautiful city. If you have a chance, definitely come visit us.